Hello and welcome to the GEM Tutoring Center's video on solving a system of three equations, this time using the addition-subtraction method. So here's an example system of three equations. We're going to add and subtract equations with each other, sometimes multiplying an equation with a number so that the subtraction works or the addition works better. And we're going to end up solving for the value of one variable. Then we'll solve for the values of the remaining variables. Okay, so let's see how that's going to pan out. So the first thing we're going to do is look at equation 1 and equation 2, and we say, how can I make it so that I can add or subtract one equation from the other to eliminate one of the variables. That's what we're trying to do. We want to eliminate x, y, or z. So let's try to eliminate x, and this is how we would do that. First, we multiply equation 1 by the number 2. And this is what that looks like. So we'll get 2x plus 2y plus 2z equals 6. Now this is still equation 1. We haven't done anything to it other than multiplying both sides by 2. So it's still the same equation. Now what we're going to do is subtract equation 1, the one that we just made, from equation 2. And this is what that would look like. So 2x plus 3y plus 4z equals 12, and 2x plus 2y plus 2z equals 6. Okay, so now we're going to subtract these equations. So 2x minus 2x is 0. So there we go. We eliminated the variable x. Now let's see what's left over. Plus 3y minus 2y, so that's just a y. And then plus 4 minus 2 leaves plus 2z. And then we have 12 minus 6 on the other side of the equation, which is 6. Now we can rearrange, we can keep this. Let's keep this as it is and call it equation 2, okay? Now the next step is to multiply the original equation 1, which is this one, x plus y plus z equals 3. We're gonna, so this was the first step, okay? This was the second step. Now we're on the third step. Multiply equation 1 by 5. Now why would we do that? So between equation 1 and 2, we eliminated x, and we were left with an equation that has just y and z in it. Now what we want to do is pair equation 1 with equation 3 and see if we can get an equation that has only y and z in it, so that we can pair those two y and z equations and then solve for y or z. Okay, so we can only pair each equation with the other equation once. So 1 can be paired with 2 once, as we just did, and 1 can be paired with 3 also just once. So let's pair 1 with 3. So how would we eliminate x from after adding or subtracting equations 1 and 3? Well, we can multiply equation 1 by 5 and get 5x plus 5y plus 5z equals 15. And then we can subtract the equation 3 from that, and we'll get rid of the x's. We'll have 15x minus 15x. Let's see what we'll get when we do that. We'll also have y and z terms in the result. So let's do that. So multiply equation 1 by 5. Equation 1 it was x plus y plus z equals 3, so we get 5x plus 5y plus 5z equals, and then 3 times 5, which is 15. So this is equation 1. All right, so we did that. Now let's subtract equation 3 from equation 1. Now I'll write down equation 1 and 3, okay? So first I'm going to write down our modified equation 1, which is this. And I'm going to write the other equation under it, which is 5x plus y plus 2z equals 11, okay? So this is equation 1 and this is equation 3. Now I'm going to do the subtraction. So 5x and 5x cancel out, so we get 0. And then plus 5y minus y, which is going to be plus 4y. And 5z minus 2z, which is 3z. And then equals 15 minus 11, which is 4. Okay, we're going to call this the new equation 3. Okay, so now let's summarize the equations we have now. Okay, the ones that we're going to use right now. We had one from up here, y plus 2z equals 6. Okay, we called that equation 2. And this one, which is 4y plus 3z equals 4. We called that equation 3. Okay, so what we now are going to do is we're going to pair these two equations up, and we're going to eliminate one of the variables by doing addition or subtraction of the equations. So what we're going to do is we will multiply equation 2 by 4, so we get the 4y here, and then we're going to subtract to get rid of the y's. Okay, so let's first multiply equation 2 by 4. So that will become 4y plus 8z equals 24. Okay, the next step is subtract equation 3 from 2. So equation 3 was this one, equation 2 is this one. Excuse me, equation 2 is this one because this is a modified one. So we want to subtract this one, this equation 3, from this equation 2, okay? I know we've been saying they're both 2, but as we change things, we're renaming them so that we don't have to go to very high numbers and stuff of equation numbers. We just want to keep things simple. Okay, so we're going to subtract equation 3 from equation 2. So equation 2 goes first. Equation 2 is 4y plus 8z equals 24. And we're going to subtract equation 3. So that's 4y plus 3z equals 4. Okay, we're going to subtract now. So the 4's cancel out, so we get 0. And then plus 8 minus 3, which is 5z. And 24 minus 4, which is 20. So we simplify this and we get z equals 4. So we have actually solved one of the values of the variables for z. Now we say, okay, using this value of z that I have, can I get the value of y? And we look back at what we had, and here is an equation that has just y in it and z in it. So if we move this to the other side, we can actually solve for y. So y equals 6 minus 2z. Okay, now let's use this equation, y equals 6 minus 2z. Okay, y equals 6 minus 2z. Z is 4, so it's going to be 6 minus 2 times 4, which equals 6 minus 8, which equals negative 2. So y equals negative 2 is the solution of one of the other variables. So you have both z and y now. Now the question we want to ask is, given the values of y and z, is there an easy way for us to find the value of x? And let's just look through our work to see if there is such an equation. And yes, there is. Right up here, x plus y plus z equals 3. We can rewrite this as x equals 3 minus y minus z. Okay? And now we can plug in the values of y and z to get x. So let's put that down here. So let's do that. X equals 3 minus y minus z. X equals 3 minus y minus z. So x equals 3 minus negative 2 minus, what was the value of z? It was 4. So 4. So then we get 3, negative, negative mixed positive, minus 4. So this is 5 minus 4, and this is equal to 1. So x equals 1. So we've solved for all three variables, x, y, and z. So the solution is x equals 1, y equals negative 2, and z equals 4. This is the solution to the system of 3 equations. Thanks for watching, and please subscribe if you'd like to hear about when we make new videos. Please keep posted for new videos that are coming out, and looking forward to see you in the next video. Thank you.